And now this is the 7th lectures in fluid statics. Okay, in chapter 3. Still we are in section 3-2, which is about pressure measurement devices. Now this is an example that I want to discuss with you. What do we have in this example? Let us read it together. So two chambers with the same fluid at their base are separated by a piston whose weight is 25 Newton. So I have two chambers, and so this is one chamber, this is another chamber, and with the same fluid at their bases. So this is water, as you can see, at their base, and they are separated by a piston whose weight is 25 Newton. And in between there is this piston, and you are given the weight of this piston, which is 25 Newton. He's asking for calculate the gauge pressures in chambers A and B. He wants the gauge pressure here, and he wants to gauge pressure there. So the question is how we are going to tackle this problem. As usual, the first thing to think about is the assumptions. So what are the assumptions here? The first assumption or fact, so you can take the water density of the water to be 1000 kilogram per meter cube. That is by setting the temperature. So I will just say the density of water to be 1000 kilogram per meter cube. So water is incompressible substance and its density is 1000 kilogram per meter cube. Then the second thing is, as we said before, we will say that any 2 points chosen in a static fluid at the same elevation connected by the same fluid will have the same pressure. And the third important assumption is in air, for example, in this chamber, if you choose any point here or there, the pressure will be the same. So I can say that the pressure in the chamber is the same as the pressure at point A. The pressure in this chamber B is the same as the pressure in point D. So those are the three main assumptions that we have to consider. So the question again is how to find the gauge pressure. He's asking for the gauge pressure. Okay, how to find the gauge pressure in chamber A and chamber B. So we want to find 2 points that are connected by the same fluid at the same elevation, and we say they have the same pressure. So I believe we can concentrate on this point, which is point E, and then we can say that the pressure at point E is equal to the pressure at this point. Let us call it F. Okay. So we can say that the pressure at point E is equal to the pressure at point F. But how to find the pressure at point F? We have to consider the pressure which is caused by this piston on point C plus this head pressure. So how to find the pressure at point C? So we can say that PC is equal to F divided by A. And F here is just the force, which is the weight of the piston, which is 25 newtons. So the question is how to find A, which is the area of this piston. This piston is circular in shape, so it got a diameter of 30 centimeters. So area of a circle is equal to pi d squared over 4. You know this. So what you have to do then is to substitute the area of, let us say, of the piston. Here you can calculate it. You know that the d is equal to 0.3 meter. So you square it, you multiply by pi, divide by 4, you substitute here, and you will get PC. Once you get PC, then you add to it the pressure which is caused by, let us say, this head. So how to do this? You just change the color. So this pressure is equal to rho GH, and the density is known, G is known, and H is this head here, which is 25. H is equal to, this H is equal to 25 centimeter. So once you do this, you add these together, and then you will get the pressure PF at this point. The next question is, so how to do it for for the pressure here, which is at this chamber. You can say again, if this is A, B, C, D, E, F, this is point G, and you can say that the pressure at this point is the same as the pressure at this point. Okay, let me just erase all this stuff. So then you can say the pressure at this point is the same as we said, the pressure at this point is equal to PG. So I will say PG is equal to PB, which is the same as PD if you want, plus rho GH, which is this time plus rho GH, and H at this time now is equal to 0.5 meter. Okay, it's as simple as that. But let me just go through the solution with you as just given. I'll give you the solution. So the piston is in equilibrium because I have this. Let me just erase all the stuff. So the piston is in equilibrium. There is no movement here. Everything is stable, and thus the net force acting on the piston must be 0. Vertical force balance on the piston. So all of this you can just read it. All he's saying is the force. There's a force balance where he's telling you that PC, the pressure at point C, is equal to the pressure caused from atmosphere plus the pressure caused by the piston. This is all what he's saying here. And now, again, he is telling you that you can look at this one, which is the pressure of the air, and it's equal to PE, which is equal to PC, plus rho G, and this is the distance. This is the pressure of air in chamber A, this is the pressure of air in chamber B. This is what we are looking at. And since you might wonder why he is considering atmospheric pressure, because now this is the absolute. But once he changes to gauge, as you can see, he just disregards them. And this is exactly similar to what I have done previously with you. And once you solve the problem, this is you will get those answers. Okay, make sure that you get those answers. The solution is given here. You can just go through it. And notice that we got a negative sign for the pressure here. This means that this is a vacuum. Okay, this is vacuum. This is a bad color. So this is a vacuum of about 2 kilopascal, which pulls the water out. So again, let me summarize it. You have the problem. You state the assumptions, and then you solve it. Hopefully you will get those answers, okay, given here. And finally, if you wonder how we get this minus pressure, this means we have vacuum pressure.